Hello everyone, and today we're going to be going over section 1.5, which is going to be use of the distance formula. So let's get started and take a look at what we're dealing with. So the distance formula, your classic D equals RT, where D stands for distance, R stands for the rate, and T stands for the time. Alright, so let's go over a few examples. Okay, so I'm going to kind of scooch this over here so we can work. Alright, so here we go. Now, it says find the distance when the rate is 13 miles an hour and the time is 12 hours. So we start with our formula, D equals RT. Okay. Now we're told we don't know what the distance is, so D is equal to. My rate is going to be 13 miles an hour, so 13. And the time is going to be 12 hours. Now, one big thing you have to be careful of is you need to make sure that your units of time match. So, for instance, miles per hour, which means that our time units have to be in hours. And I will show you what happens when that doesn't occur so you can be prepared for that in the next slide. All right, so now let's go back to our problem. Let's finish solving this out. So we're going to do D is equal to, now 13 times 12 is going to be 156 miles. So that's how far you could get in 12 hours traveling at 13 miles per hour. Okay, and that's how this works. It's pretty simple. All right, so let's go to the next one. Now in this case, okay, find the rate this time when your distance is 150 miles and your time is 10 hours. So we start with our formula, D equals RT. Okay. Now this time, I don't know. I know the distance is 150 miles. My rate, I don't know what that is. But my time is going to be in 10 hours. Okay. So let's get started. So 150 equals 10R, because 10 times R is 10R. Divide by 10. So therefore 15 is equal to R. Now you have to be careful with your units. Okay, we're going miles, so we're going to be miles, and that's in 10 hours, so miles per hour. And there's that one. Okay, let's do the third one. Here we go. So, oops, I seem to have copied the same thing twice. So here's what we can do, because I fixed it on your note sheet. Okay, so let's get rid of this. Let's make the distance 100 miles. You know what? I'm just going to do this. Bear with me a second. That's what happens when you're trying to make movies really early in the morning. I'm just going to do this. Let's get rid of that. Yeah, you can go up there now. Thank you so much. All right, so let's do one. We're going to say the distance is going to be 100 miles. Okay. We're going to say that the rate, let's say we're traveling at 10 miles per hour. And I want you to find the time. Okay. So start this, and scooch this up a little bit so we can work. There we go. So let's begin. So our distance, D equals RT. Okay. Distance is going to be 100. My rate is 10 miles per hour. Time, I don't know what that is, so that just becomes T. Okay. So let's do this up. 100 is equal to 10t, because I'm going to multiply the 10 and the t. Solve the equation, divide by 10. I have to shrink this down because my writing's so huge. Sorry about that. Therefore, t is going to equal to 10. Now again, we have to realize what we're dealing with here. We're dealing with time, and it was in hours. So this is hours. Pretty simple. All right, let's move on. All right, now here's where we've got to be careful. We have to be careful with our units of time. Okay? You get on I-93 South at exit 4, traveling at 65 miles an hour. You travel at this speed for about 12 minutes. How far have you traveled? Now again, we have to watch out for our units of time. Notice that we are traveling at miles per hour. I gave you the units in minutes. Okay? So here's what students normally do. Okay? Please don't do this, but I'm just going to show you. D equals RT. So they say, okay, well, distance is equal to 65 times 12. And then they break out their handy-dandy calculator, and I say, okay, gee, 65 times 12 is going to be 780 miles. That sounds good. But if you think about this logically, okay, if you're traveling at 65 miles an hour, so what you're supposed to travel on most highways in the United States of America, and you travel for 12 minutes, you've gone 700, almost 800 miles. Does that make sense? The answer is no. And the reason why you got such a skewed answer is because your units of time are messed up. Okay, we're traveling in hours, and we have minutes of time given. So what we have to do, here, I'm just going to erase this whole thing here, start again later. What you have to do actually is we need to convert our units of time into fractions of an hour. Okay, so our conversion. I'm sorry, my handwriting's so awful. I forgot my pens at home. So here we go. All right, so let's convert hours to minutes. Okay, so to convert hours to minutes, you're going to take your hours and times by 60. So the number of hours you're given, you're going to times by 60. Okay. So for example, a quarter of an hour, so 0.25 times 60 is going to give you 15 minutes. That's why we say quarter past and quarter of, at least around where I am. Okay. Now, if you go into the other side, if you convert minutes to hours, okay, you're going to take your minutes given and divide by 60. So 15 minutes divided by 60 is going to give you 0.25 hours. Okay, so that's our conversion. If you're going from hours to minutes, okay, so you're going to go, if you're going hours to minutes, we're multiplying by 60. If you're going minutes to hours, we're dividing by 60. All right, so let's shrink this down so we can do some work. Kind of scooch this over here, I guess. Now, in this example that we were given, we were told we're traveling for 12 minutes. So we have to take our 12 minutes and divide it by 60 to put it in fractions of an hour because we're traveling at miles per hour. So 12 divided by 60 is going to give you 0.2. So 12 minutes is a fifth of an hour. So now that we have this, this is what goes into our equation. Okay? So D is equal to my rate, which is 65 miles an hour, for about 12, or not 12 minutes. See, I'm about to screw that up. Which is 0.2 hours. Okay. So we're going to multiply that together. So 65 times 0.2, that means your distance is about 13 miles. And again, if you think about it, that makes more sense, right? 65 miles an hour for 12 minutes is about 10 to 12 miles, right? So actually 13. Okay, so just be careful of your units of time. All right, other types of problems you're going to see in this section, okay? You have a board that is 120 inches long. Okay, you need to cut this thing into 3 pieces. Okay. The second piece is 8 inches longer than the first, and the third piece is twice as long as the second. Find the size of the pieces. All right, so we're going to have 3 pieces of wood. So here's, oh, let me turn on my pen. I'm going to try that again. All right, so we have our piece of wood. Okay, It is 120 inches long. Okay, so now we're going to cut this into 3 pieces. Now, we're told the second piece is 8 inches longer than the first piece. Well, do we know anything about the first piece? And the answer is no. So that gets X. Okay. Now, second one is we're going to do X plus 8. Okay. Now, the third piece is twice as long as the second. So the second one is X plus 8. So this is going to be 2 times X plus 8. Or 2x plus 16. Okay, so now let's put this all together. So x plus the x plus 8 plus 2x plus 16 is equal to 120. Now we're just solving. Combine like terms, you're going to get 4x plus 24 is equal to 120. Scooch it. There we go. Minus the 24, so 4x is equal to 96. And then we divide by 4. Therefore, x is going to equal to 24 inches. That's great. We've got x, but that's not what this question wanted us to do. Find the piece size of all the pieces. So this first piece, x, well, that's 24 inches. That's great. X plus 8. So add 8 to the 24. You're going to get 32 inches. And then we double that for the third piece. So that's going to be 64 inches. And there's the sizes of your boards. Piece of cake. All right, so that's the end of this video. Hope you learned a lot, and I will see you next time.